Hello, so this is stage 3 of standard 6. So this problem gives us two columns of data. One is L, which represents the length of the pendulum, and P, which represents the period of the oscillation in seconds. And the problem asks us to apply logs to both of these columns, and it's going to give us two new sets of columns, and that's going to help us to find the equation that relates L to P. So just to save some time, I already did this in my calculator. So what you do first is you enter the data for L, and then you enter the data for P. And what you're going to do after that is you're going to do log of L and log of P. And after you did that, you're going to do stack calculation, and you're going to do a linear mx plus b, and it's going to give you all the values as of right here. And I have recorded them down right here, which is log of P is 0.496869 times log of L plus negative 0.693505. So now, after we got the equation, it gives us a specific oscillation period of a pendulum, which is 8.95 seconds, and we're asked to find if the period is 8.95, what the L is going to be. So you can do this just by doing command solve on the calculator, but I'm going to go a step further since I'm asked to do so and do it algebraically. So the first step is plug in the p-value, 8.95, as you have right here. This is just a literal copy and pasting of the equation that I have written down there. So you plug it in. The second step is simplifying the equation to isolate log of L. So eventually we want L, so we're gonna put everything else in the equation on one side and then L on the other. So this is what I did. I added this number over to the left side and divided 0.49. So after this, I raised everything to the 10th power, as we have learned in previous problem. That's gonna nicely cancel the log if you raise both sides by the base of 10. So this is what I did. So this is gonna be 10 to the power of. So this is 10 to the power of this whole thing that I have derived from the last step, and 10 to the power of log. Sorry, voice crack. 10 to the power of log of L. And you go down here, this thing simplifies down to 2048.29.